All right, guys. So today, on Tuesday, right, we talked about direct variation. We talked about being able to use tables and looking at graphs. Okay. Today, we're going to actually do exactly the same thing. You're going to see like the first part of it is just a review from Tuesday. There's just a little bit of an extension, right? And that extension is in the form of equations. All right. So what we're going to talk about is direct variation, and what I want you to do, which most of you already have, is you have your worksheet. All right, so if you haven't done so already, go ahead and put your name, date, and period up at the top. Name, date, and period. All right, well, how we're going to start this is let's go ahead, and I want to go, we're actually this top section, a lot of this top section's a lot of review. What I want to go down is to the nitty-gritty down below, and that is, let's go down to the directions that are a little, almost halfway down the page. All right, right where it says determine. All right, so here we go. Let's go ahead and close read this. It says determine whether each linear constant is a direct variation. If so, state the constant of variation and write an equation for the direct variation. Now, if I was to turn around and get rid of that part right there, that is almost exactly the same that we did Tuesday. Remember, it says determine whether each linear function, which is talking about these here, okay, in table form, okay, is a direct variation. Remember, on that day, on Tuesday, we found this out because we said if two pieces of information are proportional to each other, then you would say they have a direct variation. Okay? Now remember, then we turn around, and once we find out if it's proportional, bless you, or if it has a direct variation, it then goes on. It says if so, meaning if it's yes, then we need to find out what the constant of, and the other day we called it constant of proportionality. Today it's called constant of variation, but if you remember right when we did our vocabulary, they're exactly the same thing. Constant of variation, constant of proportionality. You can flip-flop them and it means exactly the same thing. All right? What of course is different is the extension, and that extension is what we talked about earlier, and that's talking about the equation. Okay? So, before we get started, I do want to talk about the constant of variation. Remember, the constant of variation, when we found out if things are proportional, remember we want to know if they have the same unit rate. And the same unit rate was what if we had y over x, right? Remember, we always put it in form of y over x. And then remember, the constant of variation, or the constant of proportionality, is once we got that as a unit rate, we turned around and the constant of variation ends up being the top number, right? We took that top number and that was our constant of variation, or our constant of proportionality. All right? So here's what I want to talk about. Let's go up to the top really quickly. Let's write constant of, we'll use the variation today since we've already used proportionality. Okay, now, the constant of variation, all right, it is a number that is relating the x to the y. It's showing the relationship between x and y. So here is what you need to know, all right? First of all, when we talk about constant of variation, I didn't really talk a lot about this, or not much at all the other day, but mathematicians give a constant of variation a letter that represents constant of variation, and that letter is K. So anytime you see a K, especially this year as a 7th grader, that's referring to the constant of variation, or the constant of proportionality. Now, the other thing you need to know is, and like we just talked about a second ago, the constant of variation, remember, is always written as y over x. Y over x. Now, listen, I'm going to kind of like piece this together a little at a time, but here's what I want to talk about. If the constant of variation is found by putting y over x, and the constant of variation is k, can we say that y over x is the same as k? So mathematically, here's how you write that. Y over x is equal to k. Y over x is equal to k. Right? Y over x is a constant of variation. So is k. So y over x is equal to k. All right, now, listen, let's pause for a second. I'm going to do a little bit of what I did on yesterday's lesson. I'm going to go ahead and I'm going to rewind a little bit to 5th and 6th grade, okay? And then I'm going to show you why we're doing this in a bit. But let's take a one-step equation. It's going to be a division one-step equation. Let's take something like m divided by 2 is equal to 6. Now, if we're going to go ahead and solve this problem here, your 5th and 6th grade elementary teacher should have said, of course, and they probably did, is that we want to get the m by itself, all right? The mathematical way that you'll hear people say is we want to isolate the variable, get it by itself. So here's how you get m by itself, is you find out what is happening to m. In this case, we're taking the m and we're dividing it by 2. So the way you get rid of this division of 2 is you do the inverse, which means the opposite. So if m is divided by 2, here's how we get rid of it. We multiply by 2. Now there's another rule with equations. You can do anything to either side of the equal sign as long as you're fair and you do it to the other side. So if I'm multiplying by 2 here, then I have to multiply by 2 here. That's what makes it okay. Now when we multiply by 2 on both sides, here's what's going to happen. Our whole goal was to get rid of this 2. Well, that's exactly what that does. So we end up with m. On the right side of the equal sign, we have 6 times 2. Well, we can simplify that. It's 12. And so in the end, we say, oh, m is equal to 12. Well, think about it, right? 12 divided by 2 is 6? Yes. So we got the right answer. Now, here's what I want to show you. Remember yesterday's lesson, we were doing like happy face, and we were kind of joking around putting happy face, and we were showing like all the way to cross-canceling happy faces. And then it actually related to cross-canceling units. Well, this is very similar to that. You're going to see me do exactly what I did here. We're not using happy faces though, but we are using things that will look kind of weird. So here we go. The rules in math are always the same, no matter if it's a number or a letter called a variable. Here's what I mean. The goal was to get m by itself. Well, in this one, the goal is to get y by itself. So remember here, it was being divided by 2. Here, it's being divided by x. So what do we get? We got rid of 2 by doing the opposite. We multiplied by 2. Up here, I'm going to do the opposite. I'm going to multiply by x. And then remember the other rule with equations. You have to be fair. Whatever you do to one side, you have to do to the other. So guess what? Same thing here. I multiplied by x here. I need to multiply by x here. So just like these 2's canceling out, these x's are going to cancel out. So what we end up with is y equals. Now k times x, this was easy, right? 6 times 2 is 12. Well, we're not going to be like k times x is 56. Okay, it's not going to be like that, right? K times x, we can't simplify. It is just k times x. Now, at this point, you may be going, Mr. Wilkins, this is boring. Why in the world are you wasting our time? Well, here's why. Ladies and gentlemen, here is your constant of variation equation. That's where it comes from. It comes from y over x is equal to k, which has made sense to you guys. All we're doing is we're making this look different. This is the equation, y equals kx. I want to point out, again, one last time, the k is the constant of variation. We're going to come back to that. K is the constant of variation. All right, so here we go. Let's fast forward back to one of our problems, and let's take a look at problem number 6. Here we go. So we're going to find out if there's a direct variation, meaning are they proportional? And we find that out by doing step 1, which is we need to find out the unit rate. Okay, this is what we did in our lesson a few days ago. So remember, the unit rate needs to be in y over x form. Y over x, y over x. All right, so here we go. 1,500 over 6, right? Because 1,500 is y, 6 is x. Meaning it's going to be the amount paid over the number of payments that were done. I'm going to go ahead and finding a unit rate, right? The bottom number is 1. Okay? So, here's the thing. I need to divide both bottom and top by 6. So we have 1,500 divided by 6 equals 250. So there's my unit rate in y over x for the first one. Now remember, again, they're going to be proportional if all unit rates are the same. As soon as we come across one that's not the same, then it's not proportional, meaning there'd be no direct variation. Okay? However, I'm going to keep going because so far we only have one here. So here we go. Let's do it again. Y over x. So 2,750 over 11. Remember, make the bottom number 1. We're going to do that by dividing both top and bottom by 11. So 2,750 divided by 11 equals, and there we go, 250 over 1. Look at that. So far, so good. It matches. So I then have my y over x, so 4,000 over 16. I need to make it where my bottom number is 1. So I'm going to go ahead and divide both top and bottom by 16. So 4,000 divided by 16 on the top, and I end up with, again, 250. Now, if you're not sure what this means, right, it actually means 250 is the amount paid, meaning $250 per one or per payment. So every payment was $250. That's what that's saying. And so far, all three of them are the same. So we have one more to do. As long as they're the same, we got to make sure all of the ones on the table are the same. So y over x, so 5,250 over 21. I go ahead and put it over 1, so I'm going to divide bottom and top by 21. So 5,250 divided by 21 equals, and that one is also 250 over 1. Now, remember, if they're all the same, all the unit rates are the same, that means this table is all of the amount paid and the number of payments are proportional, which means all of this has a direct variation, which is the question they're asking you. So since they're proportional, we're going to put yes, because there is a direct variation. That's step 1. All that work for just the answer yes, but you have to have it. Now comes step 2. Remember the other day on step 2, we're going to go ahead and write the constant of variation. Remember, that one was easy. If we did all this work, here's the constant of variation. It's the top number. So take your unit rates. Once you have the bottom number as 1, the top number is 250. So 250. That's our constant of variation. Now comes step 3, which, ladies and gentlemen, this is our new addition to this lesson. And that is, we're going to go ahead and write the equation. Now remember, the equation we have up here, it's y equals k, it's y equals kx, where k is the constant of variation. Now here is, this is simple. You ready for this? Here we go. K is the constant of variation. We've already said 250 is the constant of variation. So instead of y equals kx, here's what we're going to put. Y equals 250x. And there's our equation. Once you found the constant of variation, you just put it where the k was, and you have your equation. And those 3 answers is your answer to number 6. So step 1 and 2, guys, exactly the same thing we were working on Tuesday. The last step, or the last part of it, you're just taking that constant of variation and put it right in front of the x, because that's where the k is and that's where it fits. What this is, believe it or not, the x and the y, remember, all of this goes with coordinate graphing. That's kind of what we're talking about here. So and this is just a little side note, but what this is saying is if you have x with an ordered pair x and y, this is saying whatever the x is, the y is 250 times greater. So if x was 1, y is 250. If x is 2, y would be 500. If x is 4, y is 1,000. So that's all this is. This equation is showing us how to figure out the ordered pair. Okay, but we don't have to worry about that right now. Okay, this is all we have to worry about. Just trying to share with you the big picture. Okay, any questions about that, especially step 3, which is the new part? Okay, here we go. The problem I want you guys to try out is problem number 4. Problem number 4. All right, go. All right, sorry, who needs more time? Okay, check with you guys in about 30 seconds to a minute. Okay, how many of you are still needing more time? Okay, about 20 more seconds, and then we're going to go ahead and share. Okay, guys, when we share, please make sure that you and your neighbor are sharing all 3 answers. Make sure they have all 3 answers, all right? 30 seconds, go. Okay, here we go. just checking to see what we have for answers. All right, what's out there? So for number 4, what did we get? C2. All right, so yes, 30. I like the way you said 34, the constant of variation, and then you said y is equal to 30x for your equation. Agree, disagree? What do you guys think? Oh, all right, a lot of agreements. Okay, so let's find out. Either you guys are did really, really well as a class, or you guys did horribly as a class. So let's find out which one it is. All right, here we go. So let's find out our unit rates. Y over x, right? So the y over the x, so the 180 over 6. Now, this is pretty nice because I'm sure a lot of us could probably do a lot of these in our head, dividing by 6, right? 6 goes into 18 3 times with the extra 0. Okay, this one here is y over x. So 240 over 8. Make it into a unit rate, right? 8 goes into 24. We're dividing by 8, right? So 8 goes into 24 3 times with the extra 0. So far, so good. 300 over 10, that's an extremely easy one because we just divide both of them by 10 and get 30 over 1. And then the last one is probably the most challenging, 360 over 12. We divide both top and bottom by 12. But yes, I know that 12 goes into 36 3 times and then with the extra 0. All right, so yes, there is a direct variation because they all have the same unit rates. And yep, looking here, right? It's already over the unit rate. I take my top number, and the constant of variation is 30. And if the constant of variation is 30, then we go ahead and write instead of y equals kx, we put y equals 30x. And you know what? You guys did well. Good job. All right. Questions about that part of the lesson?
What do you think of this no? Do you just put no?
So yeah, so that is a great question. What if it's no? Well, let's just say that this was 30 over 1. This is 25 over 1. Well, first of all, that there's no direct variation, right? They're not the same, so you'd put no. Well, constant of variation, meaning the numbers all the way across the top, they are constantly 30 in this case. But if they're not constantly 30, you would not have one particular number to put there, so there would be no constant of variation. And if there's no constant of variation, then you can't make an equation. So, yep, no would be the only answer you'd put. All right. Guys, any other questions?
Well, you still would have to show your work if it was no.
You have to show this work, but more than likely the first two won't match, so you can end there after you prove it with the first two. I mean, maybe the third one doesn't match, so you'd get to the third one, and then when that doesn't match, then it would be no.
Do you have to explain why it's no?
Your explanation is in your work, so that would be your explanation. You just have to back it up with your work, and you're okay. They don't want any sentences for an explanation, so you're okay without the sentence. All right? Yeah. All right. Here we go. All right. Let's go ahead, and we have 3 steps, right? Step 1 is find the unit rate to be able to find out if there's a direct variation. Step 2 was use that direct variation, that unit rate to find out the constant of variation and then plug it into the equation. The next problems we're going to do, same 3 steps, except there's going to be a 4th step. We're going to actually use the equation, all right? And I'll show you what that means here in a second. So here's what I want you guys to do. Let's go ahead and take a look at problem number 8. Problem number 8. Now let's go ahead and let's close read the directions here. All right, here we go. If y varies directly with x, write an equation for the direct variation. Then find each value. Now let me translate the directions for you. See where it says varies directly? Well, take a look. Varies directly. What that's saying is there is a direct variation. They're not asking you a yes or no question. They're telling you there is a direct variation. You don't have to worry about that part. Okay? So they want you to then turn around and write an equation for the direct variation afterwards, which is, of course, step 3 here. So here's how we're going to do this. We're still going to do step 1, step 2, step 3. Step 1 is going to be slightly different. So here we go. Move it up a little bit. Zoom in. All right, step 1 is we are going to write, or I should say find a unit rate in y over x form. Same thing as we did before. But the nice part is we don't have this huge table to do a bunch of them. They're actually, if you take a look on all of these, right, we had a y and an x on every single one of them. They don't have a little story or a little table that goes along with it. Look at, they're telling us what the y and the x is that they want us to use. So I do exactly that. It's y over x. So in this case, it's 12 over negative 15. Now, to find the unit rate, we need to make sure, again, the bottom number is 1. And I do know that how to get from a number to 1 is I divide by that same number. So if negative 15 divided by negative 15 gives us 1. And again, with equivalent fractions, like from elementary school, whatever I do on the bottom, I'm going to do on the top. I'm going to divide by negative 15 here. Now let me go ahead and start with a little bit of 7th grade math. I know that a positive number divided by a negative number, if they were different, our answer is negative. So I do know my answer is going to be negative. Now the numerical part, the number, I don't know because I've got to use a calculator. So I'm going to punch in 12 divided by 15 equals, and I get 8/10. So 0.8. Bless you.
Bless you.
So look, we just did step 1. We pretty much just did what we did right here. We did here. Same thing. It has a negative number, yes, but that's the same thing. Step 2, we're going to do the exact same thing for step 2. We're going to go ahead and write our constant of variation. Up here is 250. Right here is a negative 8/10. That's our constant of variation. It's just that top number. And then step 3 is the same thing as step 3 above. Instead of y equals kx, it's going to be y equals negative 8/10 x. All I did is just like we did up here, right? We just plug it in right there. All right, here we go. Step 4. Okay? Now, this is asking us. They're saying, here's a y, like this is telling you where a dot would be plotted on here. It's saying y is 12, x is negative 15. So if we were to write an ordered pair, that's what they're telling us. It says a dot is here. It's wanting us to use this equation to find out where this dot would be. But it sounds a lot harder than what it is. Look at it. It says find y when x equals 2. Here's all I'm going to do. To solve this equation, I'm going to plug in 2 for x. That's what they're saying. X is equal to 2. I'm putting 2 in for x. And so, negative times a positive is a negative. And 8/10 times 2 equals 1 6/10. So, ladies and gentlemen, y is equal to negative 1 6/10. That's all you do. They're giving you the y and the x to find your constant of variation. And then they're asking you, they're telling you here, x is 2, what would y be? You just plug it into the equation and solve it, and there it is. So it says, I mean, it's not asking you to write the ordered pair again, but if x was 2, y would be negative 1.6. So it's like going to the right 2 times, going down 1.6 times, a little more than 1 1/2. Okay, again, you don't have to worry about all that. I'm just kind of trying to show you the big picture, but this is what the math part is. Okay, any questions about this before I let you try one? So you're doing the exact same thing you did up there. You're just taking it a step further. Are you talking about right here? So this was just the equation that I wrote. The same that we wrote right here is there. All I did was take it a step further because they're asking us to plug in 2 for x. So that's what I did, and I used it to find out what y was. So that's the only thing you're doing. They're going to ask you if x is 2, then find y. So if x is 2, I simplify that and it'll tell me what y is. Okay, guys, other questions? Okay, I want you guys to try out problem 7. Try out problem 7. All right, go.
Should I put the library to say something?
Anyone need more time? Okay. I'll check with you in about a little more than 30 seconds there. Bless you. All right, guys. How many of you still need a little bit of extra time on that? Okay, give you guys about 15, 20 seconds, and then we're going to share. Okay, 30 seconds. Go ahead and turn to your neighbor and share your answer. Go.
Number 7 on the paper.
Okay, here we go. Here's what you should have had is here's your y, here's your x. I'm going to go ahead and put my y over my x, so negative 4 over 10. Okay, finding my unit rate, I need to make sure that that 10 becomes a 1. Bless you. The way I do that is I divide by 10 on bottom and on top. So a negative divided by a positive is going to be a negative, but I also have the 4 divided by 10, and I get 0.4, 4 tenths. Now, considering that, right, this here is my constant of proportionality, or constant of variation. So I'm going to go ahead and write my equation. Instead of y equals kx, it's y equals negative 4/10 x. And then they turn around and they say, well, find what the y is if x is equal to 5. So that's what they want us to plug in for x is 5. So y is going to be equal to a negative number, right? Because negative times a positive is a negative. So I'm going to go ahead and put 0.4 times 5 equals 2. Ladies and gentlemen, the y is equal to negative 2 when x is 5. So again, right, the ordered pair would be 5 and negative 2 is what it's saying. Okay, questions about that one? Okay, listen, I do want to go over this really quickly. Take a look at problem number 9. It's slightly different. And here's all I want to make sure I say. Okay? Take a look. In 7 and 8, they tell you what y and x here is here, and they're asking you to find the y when x is there, right? Y and x is here. Find y when x is that. Look at the way this is worded. Be careful. It's telling you what y and x is here, and they're starting the sentence off with find. But be careful, too. They want you to find x here when y is 18. So they're just flip-flops, too. Okay, be careful. Now, the other thing I want to say about this is some of the ones we haven't done, just be careful. It's review from previous lessons. That's why I didn't go over it. It's just review kind of problems. Okay, you'll use a little bit of knowledge that we have here, but also from previous lessons.